if you remember, was that the cathode rays were traveling in a straight path. So how we concluded it? So in the cathode ray experiment, we kept a opaque object in the tube. So this is our tube, and on this side we have the whole screen covered with zinc sulfide. I kept an opaque object in between. What happened was, all the cathode rays, they were traveling from your cathode to anode, correct? And what will happen? If they are moving in a straight path, behind the object on the screen, there we will see a shadow, and that was seen. So from that we concluded that cathode rays are moving in a straight path. The next observation, if you remember, that cathode rays were traveling from cathode to anode. This told us that the cathode rays might be negatively charged, because they are moving from negatively charged cathode to positively charged anode, and all of you know that opposite charges attract each other. We can explain this observation with another experiment. Look over here. So in this experiment, what we did, we took the tube and we kept it under a electric field. So there is another set of electrodes. This is positively charged, this is negatively charged, this is anode, and this is cathode. So the electrons that were moving from cathode to anode, they were deflected towards your positive charge, positive side of the electric field, and that's how we came to know that the charge on the cathode ray was negative. They were negatively charged. Let's see the next conclusion, that these moving particles, that these moving cathode rays have some kinetic energy. For that, what we did, we kept a small pedal, and when the cathode ray hit them, what will happen? That these pedals were moving. This told us that cathode rays are made up of the particles which have some mass, and if a particle has a mass, it has kinetic energy. So that concluded that cathode rays are made up of some particles which have negative charge on them. The next one was, cathode rays were not visible. The cathode rays were not visible to the naked eyes. So that told us that particles of cathode rays are made up of very small particles. Let's see the next thing, and it says again, as we have told, that if we cannot see something, that means it is made up of very small particles. So the conclusion came that cathode rays are negatively charged. They are made up of very small particles which have very low mass but have some mass. The last observation, or you can say the last conclusion, was that cathode rays were made up of a particle called as electron, which was not known at that time of experiments when we were doing it, but J.J. Thomson named it as the electron that we know it today. Let's do a simple question on the electron, discovery of electron, you can say cathode ray experiment. So it says that which of the following properties are possessed by cathode rays. So let's see. The very first option is dual nature. That is something we will going to study in this particular chapter, the dual behavior of matter as well as of radiation. So that is true. Electron do show a dual behavior. They can act as both wave and particles. That we will be studying later on in this chapter. So our A is correct. They were traveling with the speed of light. This is incorrect. That is, all of you know that speed of light is the highest speed achievable, and no particle can achieve it. It is only the speed of light, which is 3 into 10 to the power 8 meter per second. So we can easily say that this is not correct. They have negatively charged. We have seen that and we also concluded it. And then possesses magnetic field. That is also true. Every moving charged particle has some electric field and magnetic field associated to it. So our option D is also correct. Now that is end of the discovery of electron. The next topic that we will study will be anode rays, the discovery of proton, and will come more closer step by step to the modern structure of an atom.